Hi, this is Kishore Epuri. I'm a CPQ solution architect. I have more than 15 years of experience in building the CPQ applications for various enterprise. Okay, and I worked in the very Fortune 500 companies related to the manufacturing, semiconductor, and also the energy and power utility services. Built the CPQ ecosystem and helped in generation of the proposal, quotation, and complex pricing related solutions to them. So coming to this today topic, where I was trying to present to the external audience is how can we utilize the CPQ application or the CPQ systems by using the AI powered platforms. The reason being is nowadays we keep hearing everywhere the AI, implement the AI in every technology. So that's why we're trying to see, hey, how can we leverage the AI tools to the CPQ? What is the benefits that could be bring up to the CPQ applications by using the AI platform, having some microservices architecture kind of stuff. So we'll go in detail how it is going, how it looks like, how the deployments, how the configurations, what is the ROI we get it from utilizing this corresponding feature, and what are the current challenges use the implementations, and also the sales guys have issues in generating the quotations, getting the dynamic pricing, the complex configuration taking how much time for them to build. All this information we encapsulated in such a way by giving a microservices kind of an operation by using the AI as a base platform. Okay. So coming to this one, right? So as I mentioned, a system process in this particular architecture stands for there are 100K requests monthly could be coming up with 99.9% there will be an uptime. Means there are no issue. The key complex AI workloads will be at the enterprise level scale. We have engineered the AI in such a way that even though you've tried to hit 1000K per request immediately, the trained models will able to generate the right configuration with accuracy pricing and accuracy coding. So that's where this corresponding architecture of the tool will looks like. So going to the next slide. Okay. So as I mentioned, there's an introduction. So CPQ has much more demand coming to this. CPQ means it's configuration, pricing, and quoting. So how can we do this? Is complex configurations with the real-time data, and by using the real-time data, configure the products, accurate pricing decisions, and when if you try to give more discounts, the approval process should be in the dynamic nature. Hey, this is the most of the customers are asking this much of discount. Okay, we can able to approve this particular code with the same discount. So those kind of a training model and the dynamic and the forecasting. Okay, these are the list of codes within the quarter. How can we forecast that one? What is the expected revenue? And whenever trying to configure a model, we do an upselling kind of a thing, a guided selling. Hey, if you try to buy this particular product, okay, so you get this particular product with certain price, with less price. If you combine into a bundle, you have much more discounts, I think. But this is all like an the AI will train the corresponding backend system and suggest the user saying that, hey, this is the configuration you're trying to do. Most of the customers are trying to buy these corresponding products, and also you will save this much of amount. So these kind of AI, there are microservices behind the scenes which will try to solve and help you in getting the right configuration with the right pricing too. And coming to this, the response time by building these microservices was 200 milliseconds. It's not even a 0.2 second in the response time. And we address by utilizing this corresponding platform technology, we address the challenges like, okay, what are the providing the abstractions, the tooling necessary to deploy, they manage the AI workloads at a scale. And this particular article presents your approach. How can we build the microservices based CPQ platform that seamlessly integrate with enterprise grade reliability and developer productivity? Means this microservice can be plugged in and within that AI tools, and then that will be trained and get utilized by the CPQ platform for the better coding process. So here is the high level architecture. So one is the user request, means for example, user is trying to input some user request, okay, capturing the configuration input, whatever he's trying to want to buy, okay, he select those inputs and everything. After selecting those configuration, whatever he's required, so what will happen? It will going to call an API, which is like a background API interface that will call the microservices. Microservices already built in such a way that it take the machine learning languages, AI tools, everything will be trained, generate the product rules and the data. So for example, if I select a certain configuration, it will generate, hey, for this configuration, these are the bill of materials we can say it, or it could be a product. Those are the products that could be offered, and also this is the price that could be optimal price also will be generated for the users so that they can able to generate a quotation. So it's all included in the microservices. The way of getting the request from the user, these will orchestrate and give a flexibility and for the enterprise work. I mean, ensuring that we are handling the throttling mechanism, we are handling the multiple requests, multi-threading, all those interfaces, which again interact with the microservices, AI interface services, and supporting the infrastructure components. And we do have a synchronous API calls and also the synchronous events, streamlining of the case-by-case requirements, real-time pricing calculations, and also ensure there's no latency, and that sometimes it requires a batch processing and model training. Real-time model training will also be taken care as part of this overall architecture standpoint. And next to this one, right, if it is about the AI and the machine learning, the service integration. So what is do is we do have three level of architecture or the integration pattern. One is the gradient boosting engines, means it's handling the pricing optimization with the standard API interfaces. The second was the neural networks, the power configuration recommendations to dedicated microservices. The third one is the real time. Real time is nothing but we have the information, so dynamic price adjustments based on the market conditions. So based upon, for example, if you're trying the module of the train model will suggest a price, at the same time it will interact with the several services, microservices in the on demand on the current market conditions, and it will also adjust the pricing, dynamic pricing. So it's not only the EC infrastructure is not just for a static thing, it can be leveraged to any industry standard frameworks, including the TensorFlow serving, machine flow, and the customer interface servers builds and kind of information. So the data science team will to choose the whenever we are trying to sell this corresponding product or the architecture, the data science team can choose the appropriate serving solutions for the specific model types and the performance requirements. So and they can also provide a unified monitoring and management capabilities across the all serving frameworks, ensuring the consistency in the operational practices regardless of underlying technology. So it will come as a package, as a service, so that these microservices can be utilized to any industry framework is what the high level, the integration standpoint we are trying to build. That is the microservices service integration. And coming to this event-driven communication pattern, the next level is about, one is we talk about the integration patterns and ML thing, there's an event-based. So whenever we're trying to, okay, there's some triggers or the event-driven based architecture, whenever there are some changes is happening. So then lose couple. So for example, the enough data is not getting it. So you lose couple between the services while maintaining the data consistency and also enabling the real-time approaches. So we use the Kafka serves as a central event maintaining, handles the millions of pricing events so that it's like event driven. So a lot of pricing event, whenever we're trying to hit the request, the millions of pricing events will directly hit to the Kafka services and standardized schema, enabling the backward compatibility as the platform evolves. So the events also be taken into consideration. So it's keep on evolving the microservices and also the get the data, train the model, all those information. So event ensourcing the complete history of the pricing decisions, the configuration changes, and provides an audit trails, and then also what type of price happened in past, like last few days, and what is the history of the overall pricing, and okay, what type of products configured by the users in the over the period of the time. All those audit trails will also be available and provide for the analytics. This event store maintains the inventory records, debugging, compliance, analytical purpose, all those information. So this highly we are trying to talk about the event-driven communication patterns. And coming to the next one is the what is how we can what is the infrastructure, what is a deployment cycle looks like on this particular microservices. One is this is a multi-cloud infrastructure management. So Terraform infrastructure as a code. Okay, that is one structure. The other one is about the cross-cloud networking. So coming to the Terraform is pretty much like entire infrastructure will have modular configurations and different cloud providers, including the AWS, Azure, and Google Cloud Platform. So these are the standardized patterns for the common components. It has a built-in security controls and also cost optimization settings as well. And coming to the cross-cloud networking, it will be a mesh technology. So it will to provide a secure, encrypted communication between the services. It's an advanced traffic management, canary deployments, and the circuit breaking and automatic retires. So we leverage both of these infrastructures based upon avoiding the vendor locking. And this infrastructure code undergoes the same rigorous review and also the testing of the process as the application code, ensuring the reliability and the security at the infrastructure layer. So we use the multi-cloud infrastructure management on the high level. We talk about it. Yeah. Coming to the scalability and the performance optimizations. Any tool, anywhere, performance is very key. And also on the top of it, what is a scalability standpoint? So it's not just okay, one time you buy it or one time you install it. We need to ensure, because now the world is keep on evolving or changing very quite often. We don't want okay, this is the static thing. We cannot change anything, and the performance is like that. We cannot do improve the performance. It's not like that. This is about the performance. We ensure that the microservices are more scalable and keep on. It could be evolved as much as we can, and you can make the changes as per the industry standards and all. And coming to these auto scaling policies, respond to the both traditional metrics and also the AI specific indicators. Okay, and also horizontal ports, autoscaler configurations, and machine learning services, including custom metrics exported from the model, serving the frameworks, ensuring the scaling decisions reflect actual model performance. And coming to the performance optimization, that is one of the key characteristics. Without having the performance intelligence that we added to the way of implements we do that is the intelligent node selection algorithm that consider both cost and performance characteristics when adding a capacity. So GPU-enabled nodes are provisioned only when neural network workloads require them, optimizing the infrastructure costs while maintaining the performance SLAs. And high level, it is scalable and performance optimized as well. And coming to the deployments, okay. So everyone knows when you have a Git repository, also the microservices can also be handled by the Git repository, and the configuration and deployment manifest stored in the Gits, and the blue-green deployment. This is a new model version that is fully warmed up so that you can have the Argo CD sync automatically syncs the desired state from Git with the actual cluster state, automated testing, all those involved. The deployment pipelines, it has a zero time downtime for the deployments. For example, if you're trying to enhance new features to the microservices, you don't need quite a downtime. The pipeline is in such a way that it will automatically disconnect and connect to another models that is a well sophisticatedly connected platform, and manages the traffic also be shifted from one metrics to another metrics, and detect any degradation is happening the performance in the model performance. It will alert and say that hey, there's some issues, we have to take a look. So it was very strongly connected GitOps and the continuous deployment. Okay. The second thing is the developer experience and tooling, right? There's one is the deployments, which we already discussed. What should be the developer experience? What type of APIs that will be supported for the microservices and SDKs? So standardized APIs. Okay, so there are two types typically we look. One is the standardized and the custom APIs. But by using the self-services APIs, provide the standard interfaces for common operations like model deployment and also the feature engineering and performance monitoring. These APIs will abstract the complexity of the underlying infrastructure, allowing the developers to focus on business logic rather than the operational concerns. And the other one is the software development kits, like the Python, Java, and GoPro idiomatic interfaces for interacting with the platform services. SDKs can also used. A data scientist tooling. So the other one is about the see, we know this APIs, we know about the languages, and then the data. Data is a data scientist that will be these environments have libraries, the common tasks of feature extraction, model evaluation, and the deployments. This is about the developer experience and the tools we use. Coming to that, once we develop, the other thing is where we have to do that development. Okay, we understand that this is very scalable SDKs and also APIs and the data science. We can do local development. Okay, and also replicate the production platform architecture with the lightweight alternatives like Docker Compose configuration models, including mock ML models for these approaches enable developers to test complex workflows entirely on their local machines. They don't see because we're trying to take the backup of the production. It is a very simple mechanism or lightweight alternatives, and we can reproduce any issues or challenges in the complex workflows and increasing the development velocity. And also the platform includes a sophisticated testing frameworks for ML workloads, addressing the unique challenges of testing probabilistic system. And the testing, yes, continuous integration pipelines we have it, automated testing is available. We can have the full test lifecycle suite, we can create it so that once it is pulled from the production code base, you can run the test cases and see what is the benchmark, the performance benchmark and integration test we can do it. The CNs kind of maintains the historical performance data, automatically flagging regressions in model accuracy or interference speed. Okay. Now, integrated development environments, right? Now we have our local environment, we can do the testing. How can we connect it with the production environment, and what are the tools are necessary kind of a thing. So cloud-based environment that includes all the necessary tools, configurations for production deployment, GitHub code bases, and pre-configured workspaces accessible for any. So integration with popular IDEs through remote development extensions, enough developers, and while more benefiting from cloud-based compute process. This is high level. We are trying to explain that this is an integrated development environment which is easily integrated from the test to the dev stage and production with having the CI/CD platform. Coming to the observability and reliability. See, one is, yes, deployed is done. After once it's go live, okay, how can we calibrate the metrics? Okay, so what is the metrics collection? Okay, how the usage is happening? Okay, what are the any errors is happening in the application? How we get notified? So what are the metrics collection? How we distributed that tracing or visualization in the dashboards for the real-time visibility, any system behavior, how the system performance, what is the model behavior, and also the intelligent alerting. So ML algorithms analyze the historical metric data to establish a dynamic baseline and detect anomalies. And the other one is of the metrics collection. Prometheus captures the traditional application metrics and estimate. So typically this microservice has an ability once we go live to provide the observability and also the reliability. Is it kind of a stuff. So we know the metrics, we visualize the dashboard, the tracing thing, and also intelligence alerting if there are any issues as well. Coming to the SLI or SLO framework. Okay, this is 99.9% availability with 0.1. I mean, I can say close to the 99.9%. It was up. There's no downtime per month. So try approximately 33 minutes of downtime per month is max. And also the response time, the other one is very, say the services are not down, how the response looks like. That's what we talked in previous slides about the performance standpoint and the scalability standpoint. Coming to the performance, the events is 200 milliseconds, means the accuracy is more important also, and also the speed is also more important. 95%, the pricing calculation completed within the 200 milliseconds by using these microservices, maintaining the responsive, so user not even feel any slowness. And 50, the ML interface, because we are using the average interference of the latency enabling the real-time pricing without predictability delay is 50 milliseconds. These are the SLI service level indicators beyond traditional availability and latency metrics to include AI-specific measures. The key SLIs include the model interference accuracy, prediction consistency across replicas, and future freshness for real-time predictions. So on the high level, the downtime is very minimal, the response time is very quick, and the accuracy or suggestion to the customers is almost all very quick, and the ML interference is just at 50 milliseconds. So it's negligible. So that user will not see any slowness, and also they will always be available. That's how the framework looks like. Coming to the incident response. So we talk about the development. First, we talk about the infrastructure. We talk about the development. What are the APIs that will be utilized, and also the pipeline integration to the production. And then we observability. We looked into it. What is also any alerts or thing, and also how the downtime and looks like. And now coming to this. Okay, in the worst case, if there's any incident happen, what is the response? What is the recovery? And how can we ensure that? So because there's some issue happen in the circuit breakers preventing cascading failures, or automatically it's not getting that one. So there is an automated runbooks guide troubleshooting. So we can create it so that incident response team procedures leverage the extension. Even for those incidents, we do an automated tools so that which will be okay for this response for this one, you have to fix this score or this responding. And also we have an automated chat GPT integration, that incident management communication platform, so where user can also see the moment they get an error, that error will all be translated in the back end and guide the user, hey, there was some issue with XYZ, and just wait, we're working. We created an incident, automatically just go on. And also the disaster recovery, right? Nowadays, okay, all of a sudden, what will happen out to our critical data? So it's all running in the ML. We're trying to gather the data, train the microservices, and get the information and share the data. So what is a disaster recovery process? Okay, we always take regular backups, regular restoration tests into and all. If anything happen, so we always have a restore mechanism from our backup services and automated DNS updates as well for the traffic redirection. Yes, and coming to this important thing is about the data platform integration, right? So one task is about how the microservice architectural front end looks like. The backbone of this everything is about the data. Without having the data, even though if we try to build the microservices, yes, the output will not be get. That is the major thing. There's a Kafka backbone is there. What are the sources we are trying to consume, and who are the consumers, was how we streamline the data based upon the consumer information. So we process the millions of the pricing events daily, and the topics are organized by businesses, domain, with standardized naming conventions and retention policies. So it includes the timestamps and correlation IDs, version information, enabling the detailability, traceability, and then debugging capability. So that is about the one of the important data platform architecture, streaming architecture. Coming to the other one is about the feature store and ML data management. So the feature store serves as a central repository for ML features, ensuring the consistency between the training and also the serving environments, built on top of the Apache Fist. This is the feature store and the ML data management. So we had some batch features support the model training workflows, while online features enable the low latency retrieval during the interference. So Apache Spark for the large scale data processing with optimized algorithms for the common transformations. And also coming to the data lineage, right? So the tracking provides a complete visibility into the feature generation process from raw data services through transformation steps to final feature values. This transparency proves invaluable for debugging model issues and also ensuring the compliance with data governance requirements. And coming to the other picture is about security and compliance. This is a very important aspect, okay? So because we are dealing with the data of the organization, and also nowadays AI is trying to capture all the data and to guide us. But at the same time, we need to protect our data. And also, what is the security measures? What is the compliance? When you're trying to input a request, the request has to be resides within that our architectural and also the compliance guidance standpoint, so that it should not be spill over outside of our world. So that's why we're doing the mutual TLS, all the service to service communications occurs over mutual TLS with certificate rotation automated through certificate manager, so that it has a TLS, mutual TLS certificates, And the network policies, the moment when you're trying to send the request, the stringent segmentation between the services, limiting the communication to explicitly authorize the paths. And the other thing is the identity management. It could be no OpenID or OAuth 2.0. Definitely, it's a key-based kind of thing, or the client ID kind of OAuth roles we use it. There's nothing like a layman username and password kind of thing. It's all will be a no secure identity management of OAuth 2.0, the OpenID connects. And the secrets management, right? We store everything in the vault. Even though those keys, you cannot easily capture them. Those will be in the secured vault, and it will be the vault. To access the vault every 15 minutes, it's keep on changing your password. You need to connect to the VPN, and you need to connect to the vault management with your short, you can say one type of a password to get the key and then retrieve. Then this kind of a rotation will also be happen in the database. So these are the very key important aspects for the security and compliance, and ensure that every layer of the platform zero trust principle, that in assume no implicit trust between the components, because end of the day it is will be supporting with single sign-on with a multi-factor and enhanced capacity to utilize these back-end device services, so that they cannot tamper the data, and also a very strong mechanism to for the security standpoint. Yeah. Coming to the data privacy. One, we talk about the security, right? How we can control. We have those mechanisms of TLS, OpenID, and also the OAuth kind of a thing. And okay, privacy. So we need to have certain certain persons only can set and see the certain data within even the organization as well. There could be industry specific requirements. Hey, you can see that XY amount of price, which is the role of case should not see that price. So those kind of things also be classified in such a way with the rules thing also be embedded. Hey, okay, this particular user is just dedicated to configure the model. The price is not there because it belongs to the engineering department thing. And also the privacy preserving techniques also. So if we add that control noise to training the data and federated the learning across distributed data sets, right to be forgotten implementation. So that the moment when we done this techniques, there's a right to be forgotten implementation. The data retention and also the deletion policies automatically remove the expired data, so that you don't need to get access according to the regulatory requirements and the business policies. And the platform maintains a detailed audit logs for all data access and modifications, support compliance and reporting and forensic analysis. And coming to the other important thing is the performance optimization. We lightly touched in the previous slide, but coming to the multi-layer caching. So it's nothing but you keep on hitting the same request, it will be cached, and it gives the response very quickly and very intelligently. Even though you're trying to make the small parameter change, you get it very quickly. And the other one is database optimization. So nowadays it's like PostgreSQL instances use the advanced features, including the partitioning, parallel query execution, just-in-time compilation, NoSQL databases including MongoDB and Cassandra, handle specific workloads. And coming to the resource utilization, Spot instance handling batch processing workloads with automatic failover or to on-demand instances when Spot capacity is unavailable. ML training jobs run during the off-peak hours, which compute the resources are less expensive. There are very less resources, the training jobs will be trained and get it done. So, and this content delivery network integration accelerates the delivery of the static assets and also the API responses to global users, edge locations, catchy pricing catalogs, and the configuration data, which will reduce the latency for international customers. That is, mainly we are working on the performance optimization and the strategies. Coming to the case studies, right? We're all good. We have the microservices we talk about. How can we utilize it in the CPQ? What are the deployment strategies? What are the APIs behind the scenes? What is the performance optimization and also scalability? We are talking a lot of good things in the slides. Okay, how can we ensure this all will be work, and what are the return ROI kind of thing or the results? Okay, we did a high level analysis of this, taking into small microservices built in the system and trying to understand the capacity. So 10 times you will request the capacity and increase from 10,000 to over 100K monthly request to horizontal scaling and the performance optimization. So that even though if we try to increase the 10 times, the responsive time is 75% response time is very quick. That is which way the 800 milliseconds to under 200 milliseconds. It's a 65% time to market decrease for new features measured for production. So the newer products innovation will be very quicker and very good. Building the scalable AI powered platform requires a careful consideration of architecture, operations, and developer experience. Our microservices based CPQ platforms demonstrates the enterprise grade reliability and AI innovation can coexist when supported by appropriate platform engineering practices. All in one go, what I'm trying to tell is everywhere we are using the AI, but AI is giving a very positive results and taking that as an advantage kind of a thing, or taking that as a source for that AI powered platforms, plugging into the CPQ technologies and trying to kind of evolve how can we do a configuration, pricing, coding, very efficient, very responsive, very optimization way, and also very accurate. So it's increase and more driven with the train the models and get the robust platform engineering that will grow by using this AI to drive the business decisions. That's concluding myself. This is just focusing on that scalability, reliability, and also the greater experience. The organization can create the platforms, not only meet the current need, but also adapt to the future challenges because the landscape is keep on evolving, changing day by day in the industry standpoint by and utilize this AI powered enterprise systems. That's the major case studies and overall the presentation was provided to you guys. Hope you guys have enjoyed the presentation and thank you everyone. Have a great day. Good night. See you. Bye.